Now let's see if we can take the sine and cosine and put them on the unit circle. Now remember, the equation for the unit circle is x squared plus y squared equal to 1. And when you think about your x and your y, if I take the x squared, and this is the unit circle, my x at this point is 1 and y is 0. If I take the y value, this height, at the point x, y on the unit circle, the y value I can call the y sine theta, if this is angle theta, and x is cosine theta. So for the angle, it actually is true that the y distance here is the same as the sine of theta, and the x distance here is the cosine of theta on the unit circle, if this is equal to 1, if my radius is 1. Now we can expand that for other circles, but there's more in it than that. And so it is true that my point P that's xy, I do have P of xy exactly equal to P of cosine theta, sine theta, if we're on the unit circle, circle of radius 1. Okay. We also know that over here is the point -1, 0, because it's on the unit circle. Now, if it's -1, 0, what's the sine and what's the cosine of the angle over there? And what is that angle? That angle would be 180 degrees, or pi. Okay. This angle at this point 1, 0 would be 0 degrees, or just 0 radians. So for my 180 degree point, I would have the point x is cosine theta, y is sine theta, so that tells me that cosine of 180 degrees or cosine of pi is -1. And the sine of 180 degrees or the sine of pi is equal to 0. So I can read some of these angle measures, especially the ones that are on the quadrants, on the axes. I can read the sines and cosine directly from the unit circle. I could look at pi over 2, which would come from the point 0, 1. 0 is cosine, 1 is sine, and down here my point is 0, -1, and my point is always cosine is the x-coordinate, sine is the y-coordinate. Now, my 180 degrees that I have here, cosine and sine, I said that's pi. It's also 3 pi. Why is it 3 pi? Well, I went to pi, but if I went all the way around, I'd have 2 pi and another pi. Means that is 3 pi. And you can continue 5 pi, because these are periodic functions. They keep going around and around the unit circle. Okay, let's go back to that equation that we had for the unit circle. X squared plus y squared equals 1. I square 1, I square 0, I add them together, I get 1. I square -1, I get 1, I add it to 0, I get 1. All of these points are on the unit circle, they satisfy. But we said that x is the same as cosine theta. So, cosine theta squared plus, and y is sine theta. Sine theta squared is equal to 1. We usually take the square and write it with the cosine and write it as cosine squared theta plus sine squared theta equals 1. And so from this, that was the x squared plus y squared equal to 1 equation of the circle. We also have that cosine squared plus sine squared theta is equal to 1. And that's called the Pythagorean identity. And if you look back at your circle, what I have is, let's look at the circle. Well, look, that circle's getting kind of messy. This is something you're going to need to memorize. Cosine squared theta plus sine squared theta equals 1, Pythagorean identity, but it just comes directly from the formula for the unit circle, the equation of the unit circle, and what x and y are equal to. Now we want to think of sine and cosine as functions. So we can look at their graphs. Now we've looked at sine and cosine on the unit circle, but that helps us as far as some of the values that we can use. Angle measurement, the sine of an angle or cosine of an angle. But we want to think of this as a function. So let's first look at f of theta equal to sine of theta. Now, if you think about your unit circle, and you start here where we tend to start, and we go counterclockwise, sine is the second coordinate, because sine is the y value. So my sine starts at 0, increases because it's a y value, increases up to 1. But then over here the y's decrease to 0. And then they continue to decrease to -1, and then they start to increase again. And so as you move around the circle, the values for the sine function, if you start at 0 when the angle is 0, theta equals 0, it moves from 0 to 1 to -1 to 0 back to 0 to 1 to 0 to -1, and rotates back and forth between 1 and -1. So think about that as numbers on a graph. And I'm going to start at 0. This is my theta. And let's think about it as radian measure. I start at 0. My sine of 0 is 0. When I get to pi over 2, I have the sine equal to 1. When I get over here to pi, or 180 degrees, I am back at 0. When I get to the next value, which would be pi and a half, it's 3 pi over 2, I have a value down at -1. So since it repeats, it is regular and periodic, and the values go from 0 up and down through pi and back to here. And then when I get over to when I don't have much room left, 2 pi, I'm back to my same value 0 that I have at 0, and it repeats. So this is what my sine function looks like. Now, it doesn't stop. It continues. It is a periodic function that continues. So I can keep going over here. I'm going to run into my circle, but that's okay. It keeps going up and down and up, and it just continues. And it continues this direction. It goes down and back up and so on. Although we read from left to right, so really that's the way it goes. Now let's look at these numbers on the axes where they cross. This is the sine function, and it's 0 for the sine on the x-axis. So I have 0 and pi and 2 pi, and if I keep going, this is going to be 3 pi, and it goes down, it comes back up, and this will be 4 pi. So my sine function crosses the axis at the pi values. I could look, put my head in the way, look here and just look at this part of the axis and recognize it as sine because it goes from 2 pi, goes up to 1, through 0 to -1, back up at 4 pi. And so this is the shape of the sine curve no matter where it starts. And it always crosses the standard basic sine function at 2 pi. Now, you could look at this with numbers. Pi is about 3, so let's think about that with numbers. Pi is about 3, 2 pi is 6 point something, 3 pi is 9 point something, 4 pi then would be 12 point something. I'm multiplying the integers by pi. So I would have 3, 2, 1, 3, 4, 5, 6. So you can have axes that have numbers and not just pi's. We can have all of these, and these are all in radian measure. The values that we are looking for when we put our numbers into a function. You will not often or ever see f of 180 degrees as the sine of 180 degrees and look at it that way. When we have functions, we define functions over real numbers. And so these would be radian measures or numbers. Well, let's look at the cosine graph. F of theta is cosine theta. Oops, I erased something here. 0, negative 1. Well, when we look at the cosine, cosine starts at 1. These are the x distances, and as we move up here, the x decreases, and I go to x equal to 0, which is cosine, and then I go this way to x equals negative 1, and then to 0. So it repeats the way sine does. But when you think about it on an axis, at theta equal to 0, I already have the cosine of 0 equal to 1. So if cosine of 0 is equal to 1, it starts up here. And then at pi over 2, it's down to 0. And at pi, the cosine is negative 1. 3 pi over 2, I'm back to 0 for cosine. And then at 2 pi, I am up at 1. So that would be one period of the cosine function. Let's keep going. The cosine curve, it looks like, crosses at pi over 2 values. This would be 5 pi over 2 down to 3 pi, and then 7 pi over 2. So my cosine function, f of theta equals cosine theta, f of x equals cosine x, goes across and also does the periodic, repeat the period. And we think of it as starting at x equal to 0, the y value is 1. And then it dips and goes down and back up. But again, like we look at the sine, if I just look at a graph starting further over and not at 0, it crosses at the pi over 2 values, the odd pi over 2s. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So that's the way the cosine function crosses the axes, and that's the way you can distinguish between the two. They have the same basic shape, just one is shifted the other direction, and this is what the cosine curve looks like. And you will need to know the basic shapes. So when you study the lesson, be sure to memorize those. Don't let this equation up here scare you. It is frightening. It's one function, y equals a times the sine of b times x minus h plus k. This should look familiar because it involves that translation, shift up, down, back and forth that you've seen before. It also is true if you replace sine with cosine. So let's look at each piece and just see what we've got here. The a in the front affects the amplitude. So instead of f of x equals sine x that goes between 1 and negative 1, f of x equals 3 sine x would go between 3 and negative 3. If that's my x-axis, it would bounce up and down between 3 and negative 3 because 3 in the front multiplies the height and depth. The b that's inside the sine function, or the cosine function, that affects the number of cycles within 2 pi radians. The standard period, or one cycle of a sine or cosine, is 2 pi radians. So if this says the cosine of 2x, then that affects the number of cycles. It means there are 2 cycles. So this indicates 2 cycles in 2 pi radians, okay? Which means it would look like, if this is starting at 0 and ending at 2 pi, then my cosine, see if I can get enough of these in here, would go still between 1 and -1 because there's just a 1 in front. It would start at 1 and have 1 complete cycle in pi and another one. Am I running out of space here? No, I'm going to have to kind of move this along there. That looks kind of weird, but that's the way it looks. 1 cycle of cosine and then the second one. So it shrinks it, where our usual cosine curve would start at 0, go up, down through pi, and back up here, down, up to 2 pi. So I have 2 cycles in 2 pi radians is what this B inside here does. The H and the K, those are the standard horizontal and vertical shifts. The H equals a horizontal shift, so that if my y is equal to sine of x minus pi, that means that, make that a something not so pi-ish. Let's make it a 3, which is almost pi. That means there's a horizontal shift, and my starting point for sine, make it cosine, since I already have a bit of a cosine graph up here. So my cosine, instead of starting at 1, would be shifted over, instead of 0, would be shifted over 3 units. More to, where's pi? Here. Oh, sorry. I'm making a mess of this graph. Okay. Goes through the axis at pi over 2 and is down. Over here is pi. Oh, wait a minute. Where'd that go? I'm going to have to redraw this. I'm getting myself all messed up here. Okay. My cosine function, if I start at 0 on top, this is 2 pi, and my low point would be pi. And so cosine of x minus 3 is basically a shift over almost to pi. So this graph would shift with a minus to the right and would actually start at pi and then go down and then back up, so that there would be a shift to the right. The K, that is the vertical shift, is tacked out on the end over there, so you don't have to worry about all this chunk in the middle here. K just says I shifted up or down. So you'd pick up your whole graph and move it up or down. So let's look at a graph and some equations and try to see which one is going to match it. For this example, if you want to see what the graph is really supposed to look like, look at the lesson problem in this section. That is not quite to scale, but we'll pretend like everything is going to work the way I'm going to tell you it's going to work. We have to deal with this equation, y equals a sine or cosine of b times x minus h plus k. So this first equation, we're going to look at 2 more. This first equation is a sine. It just has a 1 in front of it, so we don't need to worry about the a. We don't have a change in amplitude. It should, as the sine curve does, go back and forth between 1 and -1. But when I look up here, it's higher than 1, and it does not go as low as -1. So there should be a k, and this indicates it's plus a half. And so if that's supposed to be a sine function generally starts at 0 and then goes up. So if this was shifted up a half to here, that's a reasonable assumption. So it would go up here and down and so on. Well, the second thing we have to look at is the 6. The 6 is the b, and what that tells us is there should be 6 cycles in 2 pi radians. Okay, 1 cycle for sine goes up and down and back up to here, which would be about, should be 2 pi, but it's not, so there are more cycles, but that's 1 cycle that would go up to about here. That's 1. And then 2, and, well, it's certainly not 6. So this is not the correct equation for this graph. So that's not correct. Okay. Let's try a second function. Let's look at y equals cosine of 4 times x minus a half plus a half. Now the cosine generally starts at 1, okay, but this one starts at a half, but remember, if it started at 1 and got shifted to one side, it would be a problem. This is still plus a half. I always check this first. It's still plus a half. So let's see what this might do. The 4 says I have more cycles. This would be 4 cycles in 2 pi. And this would be a shift. But if it's a cosine, let's start at the top and think about it starting up here. So I would have been shifted over a little bit to the right, and pardon my scale, but it should be about a half. So the shift is okay. So the shift, I can say shift checks. But I need 4 cycles, and that would be 1, 2, 3, and a little bit more. So it's not really 4 cycles. I didn't drop that far off. So the shift is okay to make this graph be a cosine. And the half is okay, but the 4, it doesn't have enough cycles. So this is not correct either. So my sine curve changed to cosine, but this was actually closer than the sine graph we looked at before. So let's find the graph that should be the correct one and see what it looks like. Y equals sine of pi x plus a half. Sine of pi x. Okay, a is still 1, goes between 1 and -1. The half is the upward shift. You can see it above 1 and above the -1. So this is okay. Pi is a little over 3. So this tells me there should be about this many cycles in 2 pi. And that's almost what we did last time. We counted a little more than 3, but not quite 4 when we looked at the cosine. So if I start here and I go 1, 2, 3, and just a little bit more would be about 3.14, which would be about pi. So this is the correct answer if I have to look at those different formulas to match it up to the graph.